Okay, so I have the tough job of covering for our colleague Trevor Graff. He is supporting another conference, an engineering-based conference right now, so I'll be presenting some slides for him before diving into my own slides. So Trevor is the hardware and integrated testing lead on the internal science team, so I'm briefly going to cover a hardware, facilities, and testing update. So for hardware, you can immediately see just from these pictures how important this area is for science. This is the hardware that will be on the lunar surface, enabling our science objectives. So we have suit hardware, we have tools hardware like geology sampling tools, and we have mobility hardware. I won't cover all of this. There just isn't time. Find me at a break and I'm happy to talk more about it. I'll point out a couple of things. Axiom Space was awarded the XEBAS task order to provide the suits and the geology tools for the Artemis 3 mission. The tools specifically, this is an area where I think we as scientists can get excited about, right? These tools are based on a government design reference set of tools that NASA engineers provided to Axiom. Axiom is taking those designs, putting their own spin on them, and providing a really wonderful set of geology tools for us to accomplish our science objectives. We've also had some increased traffic lately in the mobility arena, little mobility joke. So we'll have unpressurized and pressurized mobility assets. I encourage you, Deborah Needham's in the back of the room. If you have questions in Trevor's absence, I'm sure she'd be happy to address them as she provides a lot of coverage for us on the mobility side of things. We've also been, the testing universe in support of Artemis has really spun up lately. There is testing going on nearly daily in an incredibly diverse set of testing environments. We have the Neutral Buoyancy Lab. This is the big pool at the Johnson Space Center. That picture is taken underwater. One side of the NBL has actually been completely dedicated as a lunar terrain mock-up. We've sunk lunar regolith simulant as well as big boulders that we can do simulated operations on. We also have the active response gravity offload system that you can see here. It supported many lunar gravity offload testing events in the last couple of years. We're also developing a larger offload facilities to support dual crew member offloaded operations in support of training and development for future Artemis surface missions. We've had a lot of field testing events. I have one more slide on this on the next slide, and then I'll talk a little bit about it in the next section. We've really had an increase in cadence in testing for not just Artemis 3, but longer term Artemis missions as well. And then we have a whole host of other numerous testing environments, many of which you guys all work in. This picture is an example of the JSC Rock Yard, where we have testing events going on almost on a weekly basis in support of Artemis. So this is a really rich area right now, and it's an area where Artemis internal science team members are heavily integrated. We have leadership roles in nearly all of these testing platforms. So just a testament to Sarah's point earlier about science integration across the program. We want to make sure that there's a voice in the room to represent the science objectives for hardware and testing, and Trevor is really a leader in this area. The last slide for Trevor here is just to talk a little bit about field testing events. I know that this is an area that's of particular interest to the survey community. I won't talk about all these tests in detail, there just isn't time, but to highlight a couple of them, Jet 1 took place in the spring of 2022. It leveraged heavily two survey teams' work, the RISE team and the Geode survey teams. So shout out to those two teams for enabling the Jet 1 test. Jet 3 was the full integrated Artemis 3 mission sim, the first of its kind. I'll talk more about how critical that test has been for science and science operations here in a little bit. And then most recently, Jet 4 took place at the Nevada National Security Site in May of this year. You can see two geologists, Trevor Graff and Angela Garcia, in the spacesuit mock-up hardware out at Nevada National Security Site in front of what we were using as a Starship HLS mock-up. So you can see that these tests all include science, they all include science leadership, and they're a really key environment by which we learn a lot about how to integrate science into future surface operations. Now I'll be representing myself for the next few charts. So I am Kelsey Young. For those who don't know me, I'm the Artemis Science Flight Operations Lead, and I'm going to be talking about how we've been preparing for our science community to come on board in support of Artemis. So we are defining architecture, infrastructure, and the roles and responsibilities by which we will integrate into the flight operations community for Artemis. FOD, the Flight Operations Directorate, likes to refer to things in the plan, train, and fly mission phases. We are heavily integrated in all of them. Cindy will talk to you about the training, but I want to talk to you a little bit about a couple of the focus areas by which we are integrating science into operations. Those include defining a pre-mission science workflow in anticipation of the Artemis 3 geology team and participating scientists and instrument teams coming on board. It includes defining just key parameters of mission execution. We're looking at roles in the science evaluation room, the science back room. We're looking at what the multi-shift in a 24-hour day structure needs to look like. And this is true. I'm going to focus just for this talk in the interest of time on the surface phases of Artemis missions, but this applies also to orbital phases, including Artemis 2. We have a lot of integration work going on to figure out how science is going to have a voice in the mission, and that includes running up to the mission and during mission execution as well. We're working hard on developing the science evaluation room. I'll talk a little bit more about that in a second. And we're actually hard at work defining training flows for not just the crew, but the science team as well. It's going to be really critical for everybody who's involved in the mission to receive relevant training. So before I give specifics on all of those areas, I want to provide a little bit of background. Here is specifically for the EVA phases of Artemis missions, what the flight control team relevant to us in the science universe will look like. You can see you have a crew on the lunar surface. They're the ones that are going to be doing wonderful science for us. They will be scientists when they fly. We will provide them with wonderful training to make sure that they are a part of our science team. In the front room, the room you see on TV, the room that's in all of the movies, when you see, Apollo 13 and things like that, we'll have a flight director, we'll have somebody talking to the crew, and we'll have an EVA officer who represents all of EVA, including us in science. The senior science officer in mission control will be the ESO, the exploration science officer. They will be the senior voice on the flight control team for all of science, but they will be nothing without the SIR, the science evaluation room, which is really the science brain trust of our science community. We can't wait to get you guys online. We can't wait to get your knowledge and expertise. We can't wait to train you up on what it means and what it will look like to serve in the SIR. And you guys will be the ones that will be making the lunar science happen. We'll also have science payload teams. Renee Weber will be talking here in a few minutes about that. Encourage you to talk to her. Ryan Watkins is also here in person if you want to ask her questions about payloads. I also want to briefly intro Jet 3, as I'll be talking a little bit about the results from Jet 3 in the next couple minutes. Jet 3 was the highest fidelity Artemis EVA mission simulation ever conducted. It included a full EVA flight control team and a full SMD competitively selected science team. That science team, many of whom are in the room today, were absolutely phenomenal. They contributed to pre-mission and mission execution phases, and those lessons learned have been critical. We're not doing these tests just for the sake of doing tests. We need these tests to feed the operations development of Artemis. We're already seeing lessons learned directly benefit Artemis for things like the definition of the SIR and a whole host of other reasons. The flight control team at Jet 3 looked like the following. We had almost every single role represented that we anticipate for Artemis missions. We had the front room, we had the EVA, as we call it, the EVA MIPSR, the multi-purpose support room, and we had a full science evaluation room for the EVA shifts. Jet 5 will expand from Jet 3's successes by including 2 operational shifts to support the real-time EVA as well as the equivalent overnight shift. One area in which the Jet tests, Jet 3 and Jet 5, have been incredibly helpful is to define the pre-mission workflow by which the science team will support the mission. This is the process by which the science team will define the science objectives for the mission and help feed the traverse planning for Artemis. It will include geologic mapping. It will include generation of science traceability matrices. It will include prioritizing science stations of interest, and it will include helping the flight control team develop operational products to support the crew real time on the lunar surface. Jet 5 is deep into this process right now. Shout out to all of you in the room who are pulling long hours to make this a success. The science evaluation room, this is something that, like Sarah, keeps me up at night with excitement. This is a really rich area of development right now. We're making a ton of progress. This is the room where the science team will operate during Artemis missions. The science team, you guys will be responsible for providing real-time science feedback and making sure we get our science objectives accomplished during the mission. You will be in close physical proximity to the flight control team. You will be in the building. We expect the SIR to evolve throughout the lifetime of Artemis. What fits the needs of Artemis 3 may not fit the needs of Artemis 7, and we expect that, and we'll be developing a SIR that can support that flexibility. But it does require these mission scale tests to help validate our requirements. It was Jet 3 that allowed us to define the initial set of requirements that are now being implemented. The set of requirements from us and SMD were delivered to Mission Control in January of this year. We have space allocated. We have seen it. It is beautiful and amazing, and we are so fortunate to be able to have this space so close to the rest of Mission Control. Just a couple weeks ago, design work kicked off. I have mock-up designs in my inbox right now. Construction development will kick off this October, and we will have the SIR for Artemis 2. This is amazing. It will be in the room and in the building where it happens for any Hamilton fans. And we're just extremely lucky and excited to be able to populate this SIR moving forward. Another rich area of development right now in the science operations universe is developing training flows for science team personnel. We're developing separate training flows for both those exploration science officers and for personnel who will sit in the SIR. Those flows will include a whole host of awesome things, including operational training, familiarization training with hardware, a cadence of simulations and increasing in complexity, including large integrated sims that everybody sitting in the SIR will expect it to take part of. I have some pictures here of an example from the Jet 3 science training. The Artemis SIR training will be extensive. It'll be approximately 2 years that we anticipate these training flows taking, both for the exploration science officers and the SIR personnel. Moving forward to Jet 5, Jet 3 was this huge way that we were defining and validating requirements for Artemis. Jet 3, the reports that came out of that are already being implemented across the program. The SIR is a great example of that, but it's not the only one. In the interest of time, I couldn't put everything here, but I encourage you to check out, there was about a 10 abstract session at LPSC this year, and their abstracts are really rich in information. So if you're curious on checking out what the science team did, I refer you to those publications. Jet 5 is off to the races. The SMD selected science team is on board, many of whom are in the room here. I encourage you to ask them if you have questions about it. They have been absolutely phenomenal in working through those pre-mission workflows. We're actually doing that workflow for 2 different sites, a primary site and a secondary site, and they are putting in incredible amount of work. Next week, the entire team will be down at the Johnson Space Center to complete pre-mission training and a simulation event. The SMD objectives for Jet 5, I'm sure at this meeting next year, we can brief you on how it went, will include 2 operational shifts, what we call the execute shift and the planning shift. We'll be advancing the operations products we use to support those shifts and the shift handovers, and we'll be validating all of the requirements that we've built elsewhere. I'll wrap it up because I know we're running a little bit behind. This is a rich area of development this year. There is a lot of activity going on. Science is heavily integrated in defining how science will be integrated in the operational environment for Artemis. The SIR is being developed right now. We will be breaking ground in the fall of this year, and we will be populating that room for Artemis 2. We're working hard on the training workflows for both the exploration science officers and the SIR personnel. So many of you in this room will hopefully be going through that training here before too long. And I don't think I need to tell this community. I feel like I'm really preaching to the choir here, but these analog tests are a really critical way by which we validate how we will do this for a brand new program. And I think I just want to leave you with a similar message to Jake and Sarah, which is in this area, science is fully integrated into flight operations for Artemis, and we can't wait to get to the moon. Thanks.